Aside from the fairly straightforward question of how to format your code, perhaps the most important point of style in your code is how you name things. How you name your variables, your functions, your classes, etc. First, it's important that you follow some very basic conventions that are very well established. In the large majority of languages these days, the convention is to start variable and function or method names with a lowercase letter. The point of disagreement, though, is when your variable contains multiple words, whether to connect those words with underscores or to use what's called camel case, which is the style preferred in languages like Java and JavaScript. Camel case is so called because the individual words of the names are capitalized and so appear like humps, like on a camel. Again, whether you should use underscores or camel case depends on what language you're using. If you're using C or C++, there the general convention is to use underscores. In some languages, though, like Python, there's some inconsistency there. There really isn't one standard that's won out. So you'll see a mix of both in Python. Most other languages these days, though, have a strong preference for one or the other. Another quite strong convention is to capitalize type names, such as the name of a class in Java or, say, Python. Again, this is not totally universal. For example, C predates the establishment of this convention, so I think in most C code you'll still see that the type names aren't necessarily uppercase. As for whether these type names use underscores to separate their words or whether they use camel case, that also depends on the language. In Java and Python, though, you almost always see camel case. Lastly, an almost universal convention for names is that variables to which we assign a constant value, a value which never ever changes, those we write in all caps and we separate the words with underscores, even in languages that otherwise use camel case, like Java. So, for example, here our variable representing the value of pi, well, the value of pi never ever changes. It's never going to be anything other than 3.14159265. The only variance there is how many significant digits we're going to use. Likewise with how many pounds in a kilogram. For such variables, we want to make very clear that they shouldn't have their value modified, and while many languages will allow some construct to declare that variable unmodifiable, we still have this strong convention that constants should clearly stand out in code. The only judgment call part here is that sometimes you have a so-called constant, a value which, for the sake of your program, is not going to change, but it may be a value which you made up for the sake of your program. Like, for example, if you have some hard-coded value in your code, like, say, the display width of your program in pixels, like, let's say your program displays as 1,000 pixels wide, and always 1,000 pixels wide. Well, you wouldn't want to have this magic number 1,000 showing up constantly in your code everywhere, so you want to represent that with a variable, but the way you've designed your program, the value of that variable isn't supposed to change. So you'd have a variable in all caps, something like screen_width. What makes this an iffy case is that unlike, say, pi, which is a universal constant, something that absolutely never changes, well, the width of your program display in pixels is something that may be fixed today, but you may change your mind later, and you may want it to be a variable quantity, like maybe there's a user preference that can change it from 1,000 pixels to 800 or whatever. So it's actually quite common that some things we may want to hold as constant today, later on we're going to change our program and it won't be constant anymore. When I encounter this scenario, when I'm creating a variable which I think today I will hold constant but I'm not sure, I'll just go ahead and treat it as a constant, write it in all caps, but later if that changes, if it's no longer a constant, I simply change the name so that it's no longer in all caps. This way I don't have to waste too much time agonizing over some variable, whether it's truly going to be constant forever or not. So these are the more superficial rules for variable names, but what about the much trickier problem of coming up with properly descriptive names? The most general guideline is that the names of variables and type names, classes and so forth, those should be noun phrases, whereas the names of functions and methods, those generally should be verb phrases. After all, a variable or a type represents a thing, whereas a function or a method represents an action. The major exception to this rule, though, is that very commonly we have functions and methods whose primary purpose is to return some value. In such cases, it may make sense to name the function after what it returns. For example, if you have a function that calculates the area of a circle, it makes perfect sense to call that function area of a circle rather than something like calculate area of a circle or calc area circle or something like that. When you give a function or method a noun phrase name, it's just understood that that's what the function returns. Another key guideline in naming is to let the containing context of the thing you are naming to convey as much of the meaning as possible. And by context here, we mean the containing construct. So say, when naming variables in a function, the context is the function. When naming functions, the context is the module in which it is placed. When naming methods of a class, the context is the class. But now, what does it mean to rely upon this context? Well, for example, in a class called cat, presumably it represents a cat. If you have a method, say, eat, you definitely shouldn't call that method cat eat, you should just call it eat. Calling it cat eat would just be redundant because it's in the cat class, and anyone reading your code should be able to easily infer that, oh, this is about cats. So in your naming, when you rely upon context, that prevents you from introducing redundancies such as that, but also relying upon context is what allows us from having to give everything excessively long names. For reasons I will discuss very shortly, I believe it's actually a fool's game to even attempt to fully convey what a variable or a function or a class does just by its name. That's just not realistic without giving everything names which are hundreds of characters long, which is not something you want to do for obvious reasons. However, it's important to note that at different places in code, we have more context than in other places. At the so-called bottom level of your code, that is within the functions and methods of your code, the local variables you create and name have the context of not only that local function or method, but also the module and possibly the class which contains that function or method. Whatever the language, our code is always organized in some way into a hierarchy of namespaces. The names in your code are effectively organized into a tree. The names at the roots, the names at the top of the hierarchy, have no context on which to rely, so they have to be more specific. Those are going to be generally your longer names, your more descriptive names, whereas down the hierarchy, those names have the context of the names up the hierarchy, so they needn't individually be as descriptive. So in general, the names at the top levels of your code are going to be longer than those at the bottom level, the local variables. And understand that generally you shouldn't be concerned too much about names that seem kind of long, especially function names and class names. If you find there's some name that you have to use over and over in your code and it's cluttering up your code, making it more verbose, the better solution there is not to give the original thing a shorter name, but just to give it an alias. Another important guideline is to omit articles and prepositions, basically the small words of English, a, an, the, of, to, etc. So instead of, say, naming a variable the height of the door, you would just name it door height. I also recommend avoiding inventing any abbreviation. Widely established abbreviations, like say HR for hour, that's acceptable. What you should generally not do, especially, is try and shorten your names by taking out, say, a bunch of vowels or something along those lines. Now, this was something that programmers constantly did in the past, but it's an older style of programming. By now, most programmers have learned that such abbreviations just aren't worth it. To give you my favorite example, the Unix system call create is spelt without an E at the end. That's just stupid. It's actively hostile for anyone reading the code who isn't already very intimately familiar with that name. That's the problem with these abbreviations. Or for another example, the Unix system call fcntl. That's an abbreviation for file control. 30 years ago, someone didn't want to bother writing out file control, and now we're stuck with this almost arbitrary name that's extremely hostile to anyone who hasn't been programming Unix for 30 years. Just in general, the tiny efficiencies of such abbreviations are rarely really worth it. On the other hand, it's quite typical within a code base to coin various terms, and certain terms will naturally end up in many names throughout your code. If these terms are more than several characters long, it really is kind of bothersome to see them strewn about all over the place. Like, for example, if you're writing some networking stack, and so you refer constantly to packets, it is kind of obnoxious to have to see the full word packet in all these various names. So in such cases, I make an allowance. If it's a term being used in many various different names throughout your code, then I think it's acceptable to invent your own abbreviation. What I hope, though, that you then do is document your abbreviations. You should actually keep a central list in your documentation of these are all the non-standard abbreviations I've invented and use in my code. This level of formality is a bit bothersome, true, but it does keep you disciplined about using your abbreviations sensibly and using them consistently. What you absolutely don't want in your code is to, say, abbreviate the word packet in various different ways. That's really obnoxious. So vowel eliding abbreviations were really common in the past, and they still kind of hang around in some newer code because it's just this hangover from an earlier area of programming. Another old similar tradition which you should get away from is the use of a type prefix naming convention like what's known as Hungarian notation. Hungarian notation is so called because it's named after a Hungarian guy, Charles Simonyi, who was a programmer and executive at Microsoft. He introduced at Microsoft a naming convention in which you would prefix every variable with a letter or two signifying the type of that variable. So, for example, an int variable in C or C++ code would start with a lowercase I. The end effect is that all of your names end up looking a bit gobbledygook, and so the programmers jokingly called it Hungarian notation. Now, there are many arguments against Hungarian notation and similar prefix systems. I'll just keep it simple and say that, well, it makes code look ugly. Really ugly. The longer argument against Hungarian notation is that its supposed advantages really aren't advantages. Or at least if they ever were advantages, they aren't advantages anymore with the modern tools and languages we have. My last guideline for naming, and this is my favorite, it's one that many people overlook, is that you should simply, as much as you can get away with, avoid naming things. Or, to put it more accurately, in situations where you're having trouble coming up with a good name, if it's possible to avoid giving the thing a name at all, you should take that opportunity. Now, how do you avoid giving something a name? Well, you can't do that in all situations, of course, but say in JavaScript, if you're creating a function to pass as argument to another function, if the function is only used in that one place, if you don't need to refer to it elsewhere, you don't have to give it a name. In JavaScript, you can just create it as a function expression with no name, and you can pass it directly as an argument. Similarly, if you have an expression where the return value of that expression is used only once in your function, you don't have to first assign it to a variable. You can just use that expression directly. This spares you from having to come up with a good name to describe that return value. And this is the important part which many people fail to understand. Yes, it is best when you can give things meaningful descriptive names that easily convey to anyone reading your code what they do. That's almost always better than using something as an anonymous one-off, because you're adding descriptive information into your code. You're using names effectively as documentation. On the other hand, what many people fail to appreciate is that when you can't come up with a good name, something having no name is better than having a bad name. A bad name, at best, is just noise. It's clutter. But at worst, a bad name can easily be misleading. The broader point here about avoiding naming things is that naming things is simply very hard. This is especially the case in programming because a lot of what we do in code is very abstract. Very often we're not modeling real-world things that have names that are already established. Moreover, programming is inevitably about the details of things, and for the most part, those details have to be given names. That's just the way code works. And just consider how naming details in the real world is problematic. Consider here this diagram of all the parts of a stapler. At some point in the development of the stapler, someone in stapler design and manufacturing had to coin a name for all of these things, and those names probably took a while to be popularized across the staple manufacturing industry. And while the name in some of these cases is fairly obvious, like spring or pin, in other cases there are probably dozens of different names for any one of these components that would make just as much sense as the name that was chosen. Even once you look at these named parts, like say the carriage here, that carriage is not just a generic carriage, it's a specific carriage. It has a specific shape specific to staplers, and probably specific to this particular stapler. It has angles, curves, indentations, grooves, all those things which, if we model in code, we would have to come up with names for, because that's the only way we can deal with anything in code. I, for one, would not like to have to sit and come up with a good, meaningful, non-arbitrary name for the round fiddly bit at the end of a piece of metal. Yet this is not very far from what we end up having to do a lot when we write code. It's not surprising then that many programmers take the easy way out and don't give things good names. They often lazily give their variables and functions nearly or even totally arbitrary names. You should try very hard not to be one of those programmers, but understand that there's often only so much we can do with naming. You're not going to come up with the perfect name for everything. For many things, there just isn't a name which will fully convey what that thing is, what it does to anyone reading your code. Sometimes that's just not an option. So while you shouldn't be lazy about naming, don't sit and waste too much time trying to come up with perfect names. That's another fool's game. Last thing concerning names is you should understand when it is acceptable to use single letter names or very short abbreviated names. So, for example, there's a very strong convention that you name the counter of a loop I. That's just the generic counter name for a loop. And then within that loop, if you have another loop with a counter, you would name that J, and if you have another loop within that, you would name its counter K. Now, if you had a fourth loop nested inside the third loop, I suppose you would give it a counter named L, though generally you should avoid that deep level of nesting. When you've already gotten down to 3 levels of nested loops, you're already pushing things in terms of the complexity of your logic. Another very well-established convention is that when it comes to dimensional coordinates, it makes perfect sense just to use the names x, y, and z, because those are extremely well established. Similarly, in various mathematical operations, there's an established convention whereby the inputs to the operation are simply named a, b, c, d. Another established convention is to use n for a count of something, like most commonly for the number of things in a list or array. And because string handling is such a common task, it's very common to just use a generic s, or something like str, to signify a variable holding a string, though generally in this case, in the context, it should be clear that there's really only one string you're dealing with, otherwise it would be ambiguous of which string you're referring to. What you shouldn't do is just call a second string in your function s2 and a third string s3. You shouldn't go down that route. When you start having multiple strings between which you need to make distinctions, you should then give them both proper names. This principle actually applies well with local variables storing any other non-numbered type. Like, for example, if I have a class turtle in my code, and I deal with a single turtle object within a function, I think it's very often acceptable to name that variable simply t, or maybe turtle, just give it the same name as the class, just starting with a lowercase letter. As long as it is fairly evident from context of why we are using a turtle here, we don't really have to give it a descriptive name, unless of course the function requires us to deal with 2 turtles. In that case, don't just call the second turtle t2 or something like that. You should start giving both of the turtle variables proper names, because now you have an important distinction you need to convey. Again, context is just an essential consideration in naming. Lastly, when I follow this practice of giving generic names to local variables by simply giving them the same name as the type, if the type name is very long and I wish to abbreviate it, I do so like such. I use the starting letter from each of the component words. I find that this is a much better way of abbreviating than cutting off the ends of words or eliding over vowels.